Hi, my name is Markus Ahonen. I'm the Managing Director at NDC Networks, and I've been asked by Advantech to share a project that we did in partnership with Advantech, where we bid for and won a large project in the M2M space. Before we get started, a word about NDC Networks. We are a systems integrator, which means we do design, build, and operate for a number of different markets. We work in critical infrastructure. We work in industrial networks, and also, and as relates to this project, we work on distributed IoT networks. And our technology focus is private 4G, satellite systems, obviously the M2M part as well, as mentioned. And increasingly, we're also getting into IoT data collection and data grooming on its way to an IoT system on the back end. And these days, we're part of Cinia Limited, which is a Finnish fiber operator and systems integrator. So as I get started, I first wanted to cover some of the trends that we're seeing in IoT and how we believe that's changing. And in fact, I would say that this case is proof that the landscape in IoT projects and IoT technology as such is changing. So the background obviously is that automation and solutions that require automation are going global. So vendors of industrial equipment are shipping their hardware, but with connectivity to the home office so that they can monitor, condition, and tune and provide services. And you've also all heard this, that when people talk about IoT, they say, well, we're not really doing anything new. We were doing the same thing 10 years ago. And the truth is, yes, we were doing the same thing 10 years ago, but not at this price point. So a lot of the IoT plays in the world right now are doing the same old thing, but for a use case that can't handle hardware that costs hardware that doesn't cost 1,000 euros a piece, but rather has to be in a lower price point in order for the business case to make sense. Another thing that we're seeing, and I think this is the most relevant for our case, is that IoT projects are now becoming or are being moved from the Skunkworks project teams and from the OT network teams to IT teams. And the difference there, of course, being that the IT team usually is the one that carries the largest budget. They have the most personnel. And frankly, they're probably the most organized when it comes to running seriously big networks. And with that experience also comes, into play what their background is. So they've been playing with large IT vendors such as Cisco and Fortinet and Checkpoint and HP, and they are bringing those requirements into the IoT projects. So they'll have high expectations for the operational capability of the vendor. They'll have high expectations for cybersecurity. And frankly, a lot of IoT vendors and industrial IT vendors struggle to meet those requirements. So let's talk a little bit about the requirements that our customer had as part of this RFQ. The background was that the company needed to connect thousands of assets from around Finland over an LTE network, over a virtual private network to their central site. Pretty usual stuff for a mobile router, really. And a lot of the requirements were typical as well. So they were looking for ease of installation, so zero-touch deployment. They were looking for a device that is robust so you can use it in an outdoor environment. They were looking for reliability, so things like hardware watchdogs to ensure that no one needs to do a truck roll because the hardware fails every 10,000 hours. They wanted a management tool that you could manage thousands of devices with. And they obviously wanted to monitor the condition of all those devices. And as I clued in on the previous slide, the IoT price point was an obvious driver for the project. So in many ways a typical project, but then they laid on all kinds of new requirements that were coming from what I would call big IT requirements. So they said, we want to use a Cisco DNVPN architecture and BGP routing. We want to use our Windows PKI. We want really long certificate keys and hashes. We want to use automated certificate exchange with our X509 certificates, and we'd like to authenticate devices on these routers with 802.1x. We'd like to authenticate users using Radius. We'd like to monitor network traffic, and we'd like to look at net flow data from individual routers. And oh, by the way, we're gonna put you through an external cybersecurity consultant interrogation, and they're going to go through your operations, your hardware, your software, and all the solutions that you build to support it. And finally, we're going to ask for 24/7 support. So not really requirements that you're used to seeing in the industrial space. Usually it's just give us a router, here's a feature list, and give us your best price. So here's some more details about the project and the architecture. This slide covers more of the infrastructure side of things. In short, the customer had 2 different sites, and both sites had a virtual machine environment, and in those virtual machines they ran a Cisco CSR 1000 router. And the idea was that a remote router would connect to the routers, the Cisco routers using DNVPN, and they would use BGP to select which one to talk with, which one is the priority, and the communication would go over an LTE-M link rather than regular LTE in order to increase to improve the ease of installation, because LTE-M is supposedly better in environments where the radio signal isn't very strong. So it should be easier to install these devices, and that's what the customer was going for. Additionally, the architecture was such that only critical services run in the customer's VM, and the rest of the services should run in the Azure cloud. And just putting these together was quite a challenge, but then really came the next level of requirements, which was all the different services that we needed to put together as well. So the supporting services. First and obvious one was, of course, Web Access DMP. This was really the first time that we spent a lot of time with version 2, which is just released. And Web Access DMP was to be installed on Azure. Also, all the different services that needed to be addressed with Active Directory. So having a certificate authority, in the PKI infrastructure, using SCEP for certificate exchange, and then having support for Radius and 802.1x and getting those to work. They had to be there. They also wanted SNMP-based network monitoring and alerting. So if there are any issues with devices, they would have a way to know about and address those concerns. Other ancillary services such as NTP for timing, DNS for some internal network stuff, and then syslog and NetFlow for, again, cybersecurity related logging. And as you can see here from the slide, we selected the ICR 3211B as our choice of product that we offer to the customer. And as you can tell, because I'm here presenting about it, the project was a success. But I'd like to kind of share what we learned as part of this project, because I'm hoping that that's, maybe that's the takeaway. The first takeaway was, and this was a direct quote from our lead architect, he was positively surprised and said, we've just been adding user modules and turning on features, and the router is still working fine. And I suppose that says two things. We weren't expecting everything to go as well, and we didn't have experience of such a complex environment being built on a Connell OS router. And so we were positively surprised that everything worked so well. And a second key takeaway is it's a funny story actually. This second bullet here, I copied this word for word from a presentation that I had at an Advantech Partner Summit in 2017. Because back then we had just finalized another very similar project where we had deployed a large network successfully with Advantech. And back then, as well, the router team in Usti and the Web Access DNP team in Ireland had our back and put in the man hours to build a couple of features that were missing. And they did the same in this project as well. So thanks to both teams. We couldn't have done it without you. A separate note on Web Access DNP 2, it's worth noting that it's already a second generation of a well-designed product. But this new generation really lends itself to large networks. So I'm quite fond of the architecture where you have a nice clean UI for managing basic day-to-day stuff and let's say smaller deployments. And then if you need to manage large fleets of devices, the playbooks feature is a really good way of handling large groups, but without all the complexity that goes into the sort of logical or information architecture that goes with the concept of group. It's kind of hard to explain, but it works really well and it's very elegant. Second part is that the open API architecture really helps with all those tricky requirements that we got as part of this project as well. So the various requirements that for features that you use very seldom are used by the API. And the nice thing about that is that it keeps the main UI nice and clean, and all the complex stuff is hidden behind the API. So it makes for a nice user experience. Last lesson learned, for those looking into LTE-M as an option, it works. And the data rates aren't staggering, so we were getting 300 to 400 kilobits per second max, and over an IPsec link it's less. And the challenge with this doesn't really come with a normal IT network or with a normal IoT project. It more comes when you're working in this sort of big IT context, because normally your automation data is maybe 1 kilobit, and then your network monitoring and management traffic is 10 times as much traffic, so 10 kilobits. But then when these cybersecurity requirements are laid on heavy, then suddenly you're looking at 100x amount of traffic when you're sending log files back and forth. So for every 1 kilobit of actual payload, you're sending 110 kilobits of other traffic. And the challenge there is that the subscription, the LTE-M subscription that you were looking at, that were supposed to be cheap, you might actually be moving quite a considerable amount of data on a day-to-day basis. So it's just something to consider. Another thing about LTE-M, which was an advantage to us compared to the competition, was that one of our competitors, who was right there until the final two, if you will, their firmware was a gigabyte. And so when they had to do a firmware update, they were spending a lot of data and a lot of bandwidth and a lot of time sending that update to the device. So even though it took a while, the 14 megabytes that Connell OS firmware image was minuscule in comparison to the competition, and that was one of the reasons that we won. So I think that brings me to the final point and kind of the point of this whole presentation, which is that in this project we were faced with requirements that were influenced by an IT team that had had been used to the Cisco way of doing things and the Checkpoint and the Fortinet way of doing things. And so they wrote their requirements with those vendors in mind. And we went into the project and we started looking at those requirements, and we didn't just win on price, we also won on features. So we were able to, play a big IT game and win. And I think that was that really was a phenomenal success for us. And I'm quite proud of this and all the work that we did together with the Advantech team. So, thanks. That was our presentation. Hope it was useful. And if you ever want to get in touch and ask some more questions about how we did it, I'm happy to share anything that I'm allowed to. And here's my contact information. Thanks a lot.